All right, guys. Good morning to you. It is the 27th, second to last week of e-learning for the year. Um, let's go ahead. And before we actually get into notes, is what we're doing today. Uh, I wanted to show you guys where to find this stuff on Canvas. So I've been getting a lot of questions, like people asking where do we find these things? Well, if you go right here, there's a whole e-learning section. So I went to courses, found my course. This is semester 2, 2019-2020. And I went to home. So on home, you'll see assignments. Today's assignment, boom, right here. I tell you what's coming this week, what we're doing today, and I give you kind of like a little heads up of when grades are due and that kind of stuff. So here's where you're going to find this stuff, and I'll update this later when I get this video finished and put it online. But this is kind of like what you guys should see. So this week's assignments, there are 2 of them. We've got, boom, chapter 4 notes. I'm going to be starting that today. And we also have, looks like it's not shared right now. So I'm going to go ahead and do that now. I'll even do it in front of you guys. So I'm going to leave student view. We've got, where is it? Here we go. So it's this carrying capacity paper. Well, it's more of like a lab, and it's going to be kind of interesting to see how it works out. I'm not quite sure. There's a lot to it, and you guys don't have Word, so you can't actually go in there and mess with it. So we'll be doing a separate Google Doc and figuring all that stuff out. But for today, we're going to be going through a section of notes starting right here, slides 1 through 12. There will be a note check after this, and I'm going to try to go ahead and just make all the note checks because I know some of you guys like to just do it early and get it done in like one day instead of having to come back every day and check. So we'll go ahead and I'll try to do that and get those uploaded for you guys today. But let's go ahead and get started with today's notes. So today's notes, we're getting into chapter 4. Last week was chapter 3. This is about ecosystems and communities. So it looks at these things a little bit closer. We've already talked about food webs. We've talked about abiotic and biotic factors. We'll talk about that a little bit more this week. But we're just going to be looking at some of this stuff in a little bit more detail. So starting in section 4.1, the role of climate. So we got to talk about what climate is, how it works, how it's determined. In Earth's atmosphere, temperature, precipitation, and other environmental factors combine to produce weather and climate. Weather is the day-to-day conditions of Earth's atmosphere at a particular time and place. So you might see the Weather Channel and it's set to rain today or snow. Probably not now, but it can tell you exactly what to expect on a day-to-day basis. But that's different than climate. So weather, boom, changes every single day. You might have a series of good days, a series of really wet and rainy, nasty days. It really just depends. It's a day-by-day thing. However, climate is the average, the year-to-year conditions of temperature and precipitation, which is rainfall or snowfall in a particular region. So how hot is it on average from one month to the next, 1 year to the next, and how much rainfall do you get? Those are the 2 big ones. So right here you can kind of see an example of the temperature and precipitation for a certain area. And here it measures exactly how often it rains and when. Right here you see it kind of peaks around May, August, so fall and spring or when it rains more. Temperatures, this is probably in the northern hemisphere because temperatures are colder in the winter and they get warmer in the summer months. So also recognizes temperature in degrees Celsius, so that would be very cold if it wasn't. Some factors that determine the climate. So the long-term weather almost. So the long-term precipitation and temperature trends that you see. Some factors that determine that. One is trapping of heat by the atmosphere. We'll talk about in a little bit the greenhouse effect. Basically, sunlight comes into our atmosphere and it gets reflected back onto the earth by the atmosphere, basically keeping the heat in. And if you've ever been in a greenhouse in the middle of winter, it kind of has that name because of that. If you go into a greenhouse, the glass will let the sunlight through, but it won't let the heat out. So you end up getting a nice, warm, healthy ecosystem environment for the plants in there where they can survive and thrive. There's also the latitude. So how far north or south you are on the globe. The further north you go, you're going to have different temperatures and rainfall and precipitation compared to the equatorial latitudes, so closer to the center of the earth. That's going to affect your climate. Transportation of heat by winds and ocean currents. Ocean carries a lot of heat and a lot of energy, and it actually can release that into a certain area and make it feel a lot milder than it really is. As for heat by winds, living in Indiana, you know how crazy the winters get, right? One day it might be 60 degrees, 50 degrees, some crazy thing. Get a lot of warm air flowing up from Florida. In other days, you have it, -11 wind chill, crazy cold. That's when cold air from Canada is pushing down. So because of how wind can actually bring that energy, these air systems can affect your weather and help determine the climate overall for your certain area. The amount of precipitation, so how much rain you get, is a huge factor. It determines what kind of vegetation you're going to get, if there's vegetation at all. If you live in a desert, there's very little. You're not exactly going to have forests out in the desert. The shape and elevation of the land. If it's really tall, meaning if it's very high above sea level and it's slanted, water isn't going to really stick there. It's going to flow downwards. It's going to get out of there. Probably going to be a little bit drier. It's going to be harder to grow things there. The best places to grow things are down in valleys. So where there's like floodplains. So if it floods down in that area, it leaves a bunch of sediment that helps enrich the crops for later, enrich the soil. And the presence of certain gases in the atmosphere. We all know about like the global warming stuff. Carbon dioxide is a greenhouse gas, something that affects how much heat is actually kept in by our atmosphere. And there's other things too, like methane. So let's look at the first big one, the greenhouse effect. I've kind of been talking about this one. In addition to being the main source of energy for life on Earth, sunlight drives both the weather and climate. So sunlight is the big driving force behind why we have weather. If there was no sun, we would just be a big frozen ball of ice, and there would be no weather. It'd be just frozen everything. There would be no clouds, nothing. So sunlight drives both the weather and the climate. It determines storms when they happen because energy from the sun helps drive these storms. Climate overall, talking about the latitudes and the directness of the sunlight it gets. But temperatures on Earth generally remain within a suitable range for life because the biosphere has a natural insulating blanket, the atmosphere. So we don't see these wild temperature variations all the time. Maybe in a desert area, it can get down to freezing at night and really hot during the day. But in general, the atmosphere kind of keeps a nice, even balance of heat energy. So the temperature doesn't change too much. That's because of the greenhouse effect. Greenhouse gases, like the carbon dioxide, like the methane, water vapor, these things can trap some of the heat's energy or some of the sun's heat energy and help maintain Earth's temperature range. So basically holds on to that heat and doesn't let it go. So it basically, like on the night side, if there was no greenhouse effect on the night side of Earth, it would get very cold very quickly. So greenhouse effect is a very good thing. Yeah, so carbon dioxide, methane, and water vapor, those are the three big ones. That's what they've included in their greenhouse gases. So how does this greenhouse effect work? Well, you've got, I wish you could see my hand going there, but you've got a lot of this solar energy coming down, hitting Earth. Obviously, we go out during the day, we can look up, we can see the sunlight, we can see everything around us. So some of that light is getting through. However, what that greenhouse effect does is it basically reflects that heat back down into Earth. So the Earth's ecosystem, Earth's environment. However, kind of the dangerous part of that is human caused, well, acceleration of the greenhouse effect. How to put this? So humans, we've basically been burning fossil fuels for a long time. And it increases every year. As we get more and more people, we have to burn more fossil fuels in order to run our cars and our countries and all this different stuff. Because everybody needs electricity in this day and age. So the problem is most of the ways that we get our energy is by burning that fossil fuel, and burning fossil fuel will release a bunch of carbon dioxide. So that carbon dioxide is no longer locked into this solid piece of coal or the liquid petroleum, oil. It's now floating in the air where it can hold on to more heat. And as we get more and more carbon dioxide in our atmosphere, the more it's going to hold on to heat. So temperatures will continue to rise and rise as we release more of that into the atmosphere. Actually been a really interesting look at this particular pandemic. I mean, you could look at China. There were like satellite images of China and the smog during their pandemic. It just completely evaporated. There was nothing there. Really, really interesting to see. So it'd be interesting to see how this year with the pandemic affects overall climate trends and global warming and the greenhouse effect. But here's another example of the greenhouse effect and how it works. Sunlight comes down, it gets reflected. Some of it does, but a good portion of it also gets trapped as heat. So weird fact, actually. You look up at the moon. Moon is actually reflecting less light than we do. So Earth reflects more light than the moon does, but the moon's really cold. You know why? It has no atmosphere. There is no way to hold on to that heat energy that hits its surface. So, it would be interesting to see if it actually had an atmosphere, how that would affect temperatures on the moon. Moving on. Sorry. The effect of latitude on climate. So here's the big one. How far north or south you are. Due to differences in latitude and the angle of heating, Earth has three main climate zones. Polar, which is the North and South Pole. Temperate, and tropical. So we live in temperate. More of like a temperate forest area. Like we live in, Brown County. So lots of trees. It's temperate. So basically we have fall or summer and winter. There's a time of season when the trees lose their leaves and they don't have them for all of winter. That's typical of a temperate forest. So we're into temperate regions. Tropical ones, they have green trees all year round. Doesn't matter. Because they don't have really cold temperatures. It's not going to freeze out most of the plants and kill them. So, what does this due to? I kind of want to touch on this angle of heating. Basically, as you get further away from the equator, the directness of the sunlight is not as strong. So, let me put it to you this way. So let's say you're laying out trying to get a tan. When would be the best time to go out and try to get a tan? At noon, when the sunlight is most direct and it's out there, it's hot, you're feeling it. Or would it be around 7 o'clock at night when the sun's kind of going down, you see it at an angle? Is it warmer then, or is it warmer during noon? Like right when it's the middle of the day, you're getting the most direct sunlight that you possibly can. It's obviously going to be noon, right? That's because the directness of the sunlight, you are receiving more direct sunlight. So your skin's going to soak up more of that, and you're going to get either burned or more tan. So, the directness of the sunlight has a big influence on what type of climate an area has. So here's Earth's climate zones. We've got tropical right to the north and south of the equator, which is, of course, right there at 0 degrees. From 30 to 60 degrees north and south, we have our temperate zones. So pretty much all of the continental U.S., pretty much all the continental U.S. is sitting right there in the temperate zone. Florida down there, it's kind of in the tropical zone. Lucky guys. And then you got the polar zone up here to the north and the south. Basically, it's cold year-round. It's frozen. And it's a kind of a wasteland. Heat transport. So heat transport in the biosphere. Let's come back to the wind currents and the ocean currents. The unequal heating of the Earth's surface, remember, directness of the sunlight relates to how warm it is, drives winds and ocean currents, which move heat through the biosphere. So what does that mean? Let's look down here. We've got a big, strong red current, which means warm waters, heading from here in the Gulf of Mexico all the way up to England, right? England, for its latitude, should be pretty cold. Like if you compare it to other places like Russia, it's pretty warm, right? It's pretty mild. That is 100% due to these warm currents, ocean currents moving out there. And when they get there, they release their heat energy into England. England. So, or all the countries, British Isles. So they release all of their heat energy as they get up there, and then they cool down, and then they cycle back through, right? It's a continuously moving water cycle, or water current. So the temperature of the water, the type of waters that you have, can have a huge impact on really just your overall climate, your weather from one day to the next, and the climate from year to year. The movement of water and air creates the prevailing winds and water currents, or some of the water currents, I should say. So the surface ocean currents are really driven by the heating of the planet. So let's go ahead and take a look at these ocean currents. California, sorry, you've got cold currents coming through there. So if you've ever tried to go out into the ocean, like San Francisco, it's chilly. Like I would not do it. I think most people don't really go out into the ocean there. However, if you go down to Florida and along the East Coast, people go to the beach all the time there. It's nice, warm water. It's not really that bad. It's because you have all this water that's been heated right here near the equator coming right up north, and it's going right along the coast. And it ends up, like I said before, over here in the British Isles, where it just releases this heat energy and heats everything up. Okay. last slide, because I do believe, yeah, I'm getting close to 20 minutes. Okay, so the effect of water and land masses. Water can cool or heat the air above, affecting weather on nearby land masses. And this is exactly, well, no, it's something different. Okay. So this is looking at the West Coast. Geographical boundaries can also affect weather and climate. For example, mountains. So, oh no, this is like what I was talking about with England. So the warm water can release that energy and make it warmer than it normally would be at that latitude. And geographical boundaries can also affect weather and climate. If you look at the continental U.S. once again, which near and dear to our hearts, you have this kind of situation. Basically, you have this cold, moist air coming off of the Pacific Ocean, and then it hits the Rocky Mountains, right? And along that, as it rises up, the temperature goes down. When the temperature goes down, the dew point goes down. Or the dew point goes up. No, it's an inverse thing. Maybe. Yeah. Or the amount of water that has to get let out goes up. So as this cool, moist air goes up that mountainside, it dumps all of its water in the form of precipitation in one form or another. Lower altitudes probably going to be rain. Higher ones is going to be snow, which is why the Rocky Mountains are covered in snow. And then as it comes off the other side, it's going to be very warm and dry air. That's why you have a desert right to the east of the Rocky Mountains. You have all that water. Yeah, let's look. You have all of this water, cool, moist air coming off the Pacific Ocean, hitting the Rocky Mountains. And exactly to the east of it, you have this giant desert. Why is that? Well, all that air has dumped its moisture out. It's dumped its water out as it crossed over the mountains. So it results in this giant desert area. Or, well, I don't know. We got prairies over here. So prairies, they're also pretty dry. Anyway, that's where I'm going to leave it today. I'm going to try to get those quizzes up for you guys. And we will continue with this tomorrow. All right, guys. I'll see you, and stay classy.